We are live. What's up, guys? This is Dem Keys, and today, give me a second. I'm not sure if we have. Yeah, I hope there's no audio interference. I mean, I've started the stream already. It's whatever. I'll deal with it later on. So, what's up, guys? This is Dem Keys, and today we are finally learning practical linear regression, or we are finally doing linear regression practically. And I'm not even talking about like the decision tree regression, which I was introduced to through Kaggle. I'm talking about just linear regression. So I've been doing research on that. I've been trying to understand the algorithm, trying to understand the training process, and I'm kind of there. I'm almost there. So far, okay. Here's the information that I have so far. The way that I've learned so far. Why do I keep saying so far? The way that I've learned that we do linear regression is we create an object of we create an object of the linear regression class, and then we fit the data that we have, which is the features or the input, along with along with along with, I guess they're called no, they're not called samples, are they? I think they're called samples. Yeah, we fit, actually, not, okay, did I say features? I think, right. See, there's my confusion. Either way, okay. This is the thing that I'm trying to understand. So far, what I've understood is that we create the linear regression object, and then we call the fit method to fit the model with some data. I'm still trying to get a better understanding of exactly what we are fitting there. And after that, we call the predict method, which is gonna do the prediction for us. Now, when we call fit, apparently training happens within that method itself, at least for this specific type of linear regression. The apparently the training happens like internally itself. It uses something called ordinary least squares to minimize the error, and it then calculates the weights based on that. So you then use those weights, or rather, I should say, those weights get used when you pass new input into the predict method. This is my understanding so far. What I'm trying to do is understand. What I'm trying to do is understand what kind of data I'm passing into the fit method. And at some point, I want to also visualize the line of best fit, because apparently that's what's happening. It in the fit method, it calculates the line of best fit, or rather the line that best fits within the set of data points that you give it. Which again, I need to visualize that as well. So I want to, at some point, I want to visualize the data points, and or rather I should say the training data, not the test data. I want to visualize the training data, and I also want to visualize the line of best fit. And then I want to see what kind of result it gives when I pass it some test data. So far, like, just calling it training data and test data seems like the best way to go about. I mean, it is training data and test data, but in practice, in implementation, it's a little different. Because like in fit, you're supposed to pass in the training data. In predict, you're supposed to pass in the test data, which is your new data. And there's a lot for me to explore here because I need to see what part of the data set I'm supposed to pass in for training and what part should be for testing. Should I pass in the entire data set or pass in like a slice of the data set? I need to see I need to see what the difference is in the result between, you know, passing in different parts of the data set versus the entire data set. There's a lot for me to explore, and I've been doing that today before stream. I've been chatting with Google Gemini quite a bit to get an understanding of this. Once I've gotten an understanding of linear regression itself, I mean, there's going to be like a lot for me to play around with in linear regression alone. But once I've gotten an understanding of it, then I can move to what do you call it? Then I can move to decision tree regression. And okay, so I was supposed to be learning clustering, but I kind of got distracted at some point and I ended up going back to linear regression, which I'm happy about. Oh, also there's a bunch of these other methods that I need to explore as well to see what exactly they do, what they're used for. But yeah, we do need to get back to clustering at some point whenever I get to it, because I'm yet to look into any of these clustering methods, to be honest. We kind of started looking into clustering in the last stream, but I ended up getting distracted with a bunch of other stuff. Which, I mean, that wasn't really a bad thing because I kind of needed to refresh my knowledge on a couple of things, and that knowledge has helped me with other stuff, not just clustering. But yeah, I do want to get back into the clustering thing, and dude, we need to get back to PyTorch. I need to somehow, I need to somehow get back to PyTorch. Otherwise, I'm just never gonna finish it. I got super distracted in between with a bunch of other things. Uh, should I leave linear regression for off stream and we'll just do PyTorch now instead? I could do that. I could do that because the linear regression thing requires me to. Okay, okay. Right now, I've been trying to understand what kind of data I'm passing into the fit method, and looking at the documentation here, it says the fit method is used to fit the linear model. You pass it x and y. X is the training data, and y are the target values. X should be an array of shape n samples and n features. Okay, okay. And then, wait, hold on. An array of shape n samples and n features. So this is supposed to be, it's, so far I've understood. Why am I saying so far? I mean, technically it's not wrong. So far what information I've been getting is that the fit method is expecting a 2D array. Yeah. So far, what I've been getting is that it's expecting a 2D array for X specifically. For X, it's expecting a 2D array. And over here, I'm seeing that for y, it either accepts a it either accepts a 1D array, which is just the samples, or a 2D array, which is the samples and the targets. Oh, this is interesting. We can also pass it individual weights for each sample. That'll be good for me for when I wanna actually do the calculations myself. That would be interesting. That would definitely be interesting. Okay, so um, I'm learning this, I'm trying to visualize how this calculation is going to be happening, or rather I'm trying to visualize this thing on, well, I'm trying to mentally visualize it on I'm trying to mentally visualize it on sorry, got distracted. I'm trying to mentally visualize it as as a graph, actually both a scatter plot and a line graph together. The line graph is for the line of best fit, and the scatter plot is for well, the data points. I'm trying to visualize it in my head. The way that I'm visualizing it so far is this. Wait, you know what? Quick thing. Okay, import. What was it? Matplotlib.pyplot, or was it pyplots? I think it's pyplot as plt. Let's just run this. If it runs, it runs, and then we know that it's right. So yeah, if it runs, then we know it's right. And it's going to take a bit to run. Okay, cool. While that does its thing, I do remember the code, so I can just do figure axes equals plt dot subplots, and then we do ax dot, oh, we need data points. We need, I think that needs to be a two-dimensional array as well, right? For the scatter plot, because we then specify x and y for each data point. So let's say, I don't know, a01 equals what, 1 on x, 1 on y. For the time being, let's just do this, and let's see what shows up. And then we can have a02, which will be our line graph. So we can draw a line from, how are we meant to specify? I don't remember what the thing was. Okay, I think that thing ran without errors. Yes, I think we are good. Okay, so ax dot, what was it, scatter? Okay, this is not cooperating. Give it a second. Okay, there it is. Okay, are we gonna take time with IntelliSense now? No. Okay, we're good. So x and y. Oh, that's how we are specifying them. So we are specifying the x of the point and the y of the point, like separately with two separate lists. We are, what is s supposed to be? Okay, x and y are, okay, s, the marker size in points. Oh, okay, okay, all right. So I guess we can do this and like see what it prints out. This should be diagonal, like 3 diagonal points. Wow, this is taking a bit. Okay, why did it not show? Oh, it was just taking some time to load. Okay. All right. There is our scatter plot. Okay, and then on the same thing, we can do a line graph. What was it? Just chart, I think, or I think it was just plot. I think it was just plot. Yeah, that's for a line graph, right? What parameters is it expecting? Just an array like. Wait, no, how are we specifying? So, okay, we have scale x, scale y. How are we specifying the parameters? If you specify multiple lines with one plot call, the kwr so and so, okay, whatever. Plot so and so, plot x and y using default line. Okay, I guess let's just plot x and y. So we are gonna plot. Let's start it at, I don't know, 1.5. This is x, right? Yeah, let's start it at 1.5. And 0, right? And then let's do, I don't know, 2.7 and 1. So that should be just like a diagonal line. Right. There is our. Oh, yeah, it's scaled accordingly. Okay. All right. So we can. Now I need to think of. I need to think of how I'm visualizing this. Okay. Well, no, not how I'm not how I'm visualizing this, but how I'm visualizing this. So we give it training data. Okay, let's read the thing again. Okay, so X is the training data and Y is the target values. X is the training data and Y is the target values. But the training data is a two-dimensional array of size n samples, n features. So the number of samples will be the number of rows, and the number of features will be the number of columns in each row. Now, if we have, okay, this is a two-dimensional array. Is it expecting 2 columns? What if I give it just one? What if I give it just 1 column? Like, if I were to plot this on a graph, how would it look? Because I'm trying to visualize this. I've tried having 1 column, 2 columns, and 3 columns. All 3 of them work. but it's still a two dimensional array. So it's one row, but then either one, two, or three columns, and all three of those work. So I'm trying to understand how this gets, like, let's say I were to plot this onto a graph. What what would that what would give me a second. Yeah, let's say I were to plot this on a graph. What would that look like? How is that being plotted? Because, okay, if we are saying X and we are saying Y, would we plot it exactly like that? Like, okay, let's say we are passing in for X, we are passing in this, and for Y, it only needs this, right? What did it say Y is supposed to be? Y's size? If Y is a one-dimensional array, it should be of size n samples. It should be of size n samples. Uh, would that be this? Because, okay, let's say we have one sample. No, it has to be a 1D array of size n samples. Meaning, if we only have one row in our X array, we should only have one value in this. Let's see if this runs or if this throws an error. Okay, no, this runs. Great, awesome. So now let's introduce another point in here. Let's say 1 and 5. This should throw an error, right? Because now we have two samples in X, but we only have one sample in Y. So that should be throwing an error. Okay, so let's give this a value, and that works then. Okay, now in terms of visualizing this, what I'm trying to understand is, well, what I'm trying to understand is how I'm meant to be visualizing this. Because I take that equation into account, which is y equals x multiplied by the weight plus bias. Though, I mean, I don't know if no, that doesn't apply here. Not just yet, because this is still, it's still fitting. Does it apply here? I'm not sure. Okay. So let's say if I were trying to visualize this, how am I meant to go about visualizing this? The features are supposed to be the input, right? Y is supposed to be the target. X is supposed to be our, I forgot what the name was for that. Have they mentioned the name here? Oh, it's just training data. Okay. X is supposed to be our training data, where we are specifying what are we specifying when we pass in X and Y? When we, okay. So what are we saying here? Let's say, like, let's try to visualize this, what I've done just now. Okay. We see the values. Okay. Let's try to visualize this. Would this be, let's give it like different numbers just so it's, okay. Would this be visualized in this way, where we do 3 here and 1, and then we do 6 and 5. So like, is this being treated as X and Y? Like, is this an accurate representation of this, or would it be more accurate to use the actual, Y as the Y? Because Y is supposed to be the target. Okay, what are we trying to say with this fit method? What we are trying to say is, for this, what we are trying to say is we are trying to calculate a line of best fit which best relates this training data to the target value. Right? Isn't that what we are trying to say? We're trying to get the model to learn this relationship and calculate weights that represent that kind of a relationship. I think that's what we're trying to do, right? Okay. Um hold on. Hold on. I have asked Gemini. Okay, you know what? Let's do this again. Um Give me a second. I'll open up one of the I'll open up Perplexity Labs thing. What was it? Labs dot or just lab? Okay, let me just Google it. Okay. All right. So let's try this. In scikit-learn's linear regression class, when I call the fit method, how is X and Y being used? When using so-and-so class, okay. All right. You just, wow, this is giving much more. I should start using this, or at least I should start including other LLMs into my research, other LLMs than just Gemini. Because I keep forgetting that there are other LLMs which give you answers in their own ways, and there are certain LLMs that are meant for coding purposes, so they can actually give you much more detailed answers. Of course, each one of these, like, uh they have their pros and cons. They have their strengths and weaknesses. Okay, when using the linear regression class from scikit-learn linear model and calling the fit method, the parameters x and y serve distinct and crucial roles in the process of training the linear regression model. X is the dependent variable. X represents the independent. Oh no, x is the independent variables. Okay, I read that wrong. Okay, x represents the independent variables or features of your data set. Okay, so that's the okay, I keep associating independent variables with input. and dependent variables with output, but I feel like I'm going to need to change that way of thinking for certain models, because otherwise the language becomes kind of confusing. Okay, it should be a 2D array-like structure where each row corresponds to a sample, and each column corresponds to a feature of that sample. Okay? For example, if you have a data set, actually, give me a second. In the next 30 seconds, there's going to be an ad playing. So I think I'm going to start the ad break right now. And I will see you guys in 30 seconds. I'll take a little hydration break in the meantime. All right, welcome back. So, okay, so each row corresponds to a sample, and each column corresponds to a feature of that sample. All right, so if I'm trying to visualize this, if I'm trying to visualize the features, I feel like the sample is going to need to be. Okay, hold on. For example, if we have a data set where each sample is described by two features, X might look like that. Okay, that makes sense. Here, each row is a sample and the columns represent the two features. Okay, Y is the dependent variable. Y represents the dependent variable or the target variable that that you are trying to predict. It should be a 1D array like structure. It should be a 1D array where each element corresponds to the target value for the respective sample in X. I feel like this is important. Okay. Okay. All right. Okay, I'm getting it. So I don't need to read this whole thing. So basically we had a 2D array here with 4 rows, and because of that we have a 1D array here with 4 values. Okay, cool. The fit method. When you call so-and-so dot fit, the linear regression model uses these x and y to find the line of best fit. No, to find the best fit line that minimizes the sum of squared errors between the predicted values and the actual values. The model estimates the coefficients and the intercept of the linear equation, so-and-so, where y is the dependent variable, x1, 2, 3, etc. are the independent variables, and I'm going to call this beta. 0, 1, so-and-so, so-and-so are the coefficients, and intercept estimated by the model. Coefficients and intercept estimated by the model. Okay. All right. I keep calling it weights and biases. I feel like I need to change. I mean, weight still kind of, I feel like I can still use the term weight, but I don't know if bias is the right term to use here, because like I brought that I brought that in from neural networks, because neural networks have weights and biases. Yeah, I feel like I need to stop using that terminology here, at least until I understand exactly what the calculation is doing. Uh, Wait, okay. When you call this, the model uses these x and y to find the best fit line. To find the best fit line. The best fit line. How is it getting a best fit line? Like if I were to visualize these data points, what would that look like? Because like here's what's confusing me. If I have, let's say, n samples, right? But I have two features per sample. And then let's say I have n samples for the target variable as well. How would that be visualized? Like, let's say we are using x to plot the x value, or let's say we are using x to decide the x value of the specific data point, and then we are using y to decide the y value of that specific data point as well. Which of these values would be used when we are plotting the thing? Or is it that when I increase the number of features past one, visualization becomes a little complicated? Because if I were to visualize it in this way, let's say I'm visualizing it in this way, this works, right? And what that means then is we have two x values and we have two y values. So if I plot this, then, oh, wow, what is, okay, okay, all right. Yeah, so this is our, can I specify like a custom, well, actually I can specify. I forgot what it was. I think it was ax dot set lim, set x lim. Okay. Uh, let's say, wait, does it take both the minimum and maximum? Left, right. Oh, I can set like multiple things. No, no, it says float, right? What if it's a tuple? What does it do then? The left and right x limbs may also be passed as the tuple. The tuple left and right as the first positional. Wait. Oh, okay, okay. So here xlim, if xlim is a float, it would be the max value. But if I pass a tuple, I can pass the min and max values, I'm guessing. So let's say I do this. What does that look like? Yep. Okay, cool. Awesome. And then let's do the same thing with this as well. Actually, let's do it like this. Okay, so these are our data points. Great. So what was I doing? Okay, so would this be an accurate representation of our data points? Like, okay, let's say I calculated the coefficient comes out to 0. The intercept does have a value, but then the intercept is telling us what the value of y would be when x is 0. Yeah, the intercept is telling us what the value of y would be when x is 0. So like, I mean, okay, we could try plotting the intercept. Let's, okay, so we only have one intercept, apparently. Why is that? Okay, let's take a look at coefficient. The coefficient is -1. The coefficient, apparently it's meant to represent the slope. How am I using this to draw a line though? Yeah, I'm not sure how I would be using this to draw the line of best fit. Okay, wait, let's go back to, why is this open? Oh, okay. Yeah, never mind. Let's go back to this. Okay, so we create and fit the model. Okay, so this is the independent variable, this is a dependent variable. I'm not sure why there's a calculation being done here for the dependent variable, but all right. So we create the independent variable and then we create the dependent variable, and we then feed this into the linear regression model to fit the model with this data. We So what's happening here, at least from my understanding, is that we are using these data points, or we are feeding these data points into the model, and then we are trying to calculate the line of best fit within these data points. Okay, let me try asking the question here. If I wanted to visualize the data points that you've fed into Reg, no, wait, the training data. I should say that. Though, okay, the training data is, okay, if I wanted to visualize the data points that you fed into the fit method, would I be using both X and Y or only X? To visual, oh, okay, all right. Um, to visualize the data points that you have fed into the fit method of a linear regression model, you would need to use both X and Y. Here's why. X X represents the independent variables or features which are typically plotted on the X-axis. Okay, that makes sense. Y represents the dependent variable or the target variable, which is typically plotted on the Y-axis. By using both X and Y, you can create a scatter plot that shows, okay, all right. X is used to plot the feature of X on the X-axis. But your X is already a two-dimensional, is already a 2D, no. But in your X array, you have, no, each sample has two features. Which feature are you choosing for the visualization? I don't think you can use both of them. When visual, all right, hold on. Let's wait for this to finish. Okay. When visualizing a linear regression model where each sample has multiple features, you cannot directly plot both features on a single plot in a way that fully represents the model. Here are some approaches to handle this. 2D plot with one feature. If you have one independent variable, no, if you have two independent variables or features and one dependent variable, you can create a 2D plot by choosing one of the independent variables to be on the x-axis and the dependent variable on the y-axis. Okay, all right. Um, in this example, wait, I don't, uh, what is going on here? I need to test this. I don't think I've indexed arrays in this way. Let me see what's going on there. So let's say, I don't know, ARR01 equals this and then this. Okay. And then we index it like this. What is this giving out? List indices must be integers or slices, not tuple. Okay. All right. Okay, so that's how I access the row. And then that's how I access the column in that row. I would not be able to do something like this, right? Okay, cool. What is this? Oh, did it mean to do this, maybe? Oh, okay, okay. I think it meant to do... No, it didn't. Hold on. That's wrong. Oh, okay. Right. So doing this gets the entire array, which then it's kind of redundant, right? It's kind of, well, yeah, it's kind of redundant. It's not necessary then. We don't need to do this. It's just unnecessary. We can just directly index it like this. Right. Okay. Fine. Let's, we can look into that later. For a more comprehensive visualization, you can use a 3D plot if you have two independent variables and one dependent variable. Okay. All right. So I'm going to take the LLM's word for it and say that, cool, we need to visualize it in this manner. So that being said, those are our data points, right? We have our x and we have our y. Y is supposed to be uh, the predicted value or the expected value, and x is supposed to be the input. So for this input, we are expecting that output. I'm assuming that is what we are trying to get the model to learn. We are trying to get the model to learn this relationship. And it learns this relationship through the line of best fit. Or, well, it learns this relationship by calculating the line of best fit, because to get to that line of best fit, it's going to have to... I was about to say that it's going to have to iterate multiple times, but no, I believe there's already like an algorithm that does that without having to iterate multiple times. I think like ordinary least squares does that. And so this was also something that I needed to kind of look into, because apparently the linear regression model doesn't need to be uh, it doesn't need to be trained multiple times. It doesn't need to be trained multiple times in the same way that you would be training a model by adjusting its weights. Let me put it that way. It doesn't need to be trained multiple times in that manner. What you need to change is the values that you're giving into that you're passing into the fit method. So it needs to be trained in that manner. I don't know if I don't know if what I just said made sense, but that's the way that I'm seeing it. So like technically there is still a bit of training that you have to do in order to get it there. But it's not in the same way that you would train a neural network, for example. Of course, I could be wrong in my assumption. Like I'm still a beginner in this. This is just what's making sense to me right now. So okay, let's say we fit the thing, right? It's calculated the coefficient and it's calculated the intercept. Okay, right. Let's talk about the best fit line. How can I use the coefficient and intercept to plot the best fit line along with the training data on a graph? Don't show me code, just tell me uh, or just explain. Okay, to plot the best fit line along with the training data on one graph, you can follow these steps using the coefficients and intercept obtained from the linear regression model. The coefficients, slope, and intercept, and the intercept, y-intercept, are typically denoted as, but okay, the y-intercept, the y-intercept tells us what the y value would be if x was 0. How how are we using this to plot the best fit line if it's telling us for each data point? Okay, let me just carry on with this. Are typically denoted as m and b in the equation on the line so and so. So y equals, oh wait, the slope is m and the y-intercept is b. Okay, so that's how we get y, because y equals mx plus b. So y equals the slope multiplied by the input plus the intercept. All all right. Okay. Okay. But if the slope is 0, because the coefficients that I've been getting here have been 0. Wait, actually in this case the slope wasn't 0. Wait, I just remembered. The coefficient was -1 and the slope was the slo no, wait, hold on. The coefficient is the slope. So the slope was -1 and the wait, doesn't -1 mean the slope is downwards? I think so. Yeah, I think so, because that's also the way that I've laid out these data points. I think so. Okay, we'll plot the thing and see. Okay, what more? What more? Intercept. Yes. Okay, so how are we calculating? How are we calculating y, or what are we using for y here? Are we using the original training data y, or where is it? Uh, plot best. I forgot Python. Okay, best fit line. Um, let's say BF01, or yeah, best fit line. Currently it only has 1 point. There's not going to be a line because it's just going to be 1 point. So how do we fix this? We probably need more. Well, there's not going to be multiple. Hold on, this is not going to work. Yeah, this is not going to work. Because to increase. Oh wait, actually no, it might. Yeah, okay, I've been thinking about this the wrong way. Wait, let's get rid of this. Okay. So we are trying to plot the best fit line, right? So the best fit line, given our coefficient and y-intercept, because we have one coefficient and y-intercept, we're gonna apply that here. And let's say, hold on, I'm not able to remember the coefficient. So the coefficient is negative 0.5, and no, wait, that's right. The coefficient is negative 1. You know what? I could just use the coefficient here directly. So L1 dot coefficient 0. That's the coefficient. So that's okay. It's mx plus b, right? Y equals mx plus b. X, that's important. X is our thing here. And then we have another thing here as well, which is this. Right. This is really messy, and like trying to plot this is also going to be a bit of a nightmare, but okay, we can do it. Um, no, is there another way that I could go about this? There has to be, no, there has to be a better way that I can go about this. So okay, I can probably change the layout to be just the X and Y. Oh, wait, no. X and Y. Right. So that's our X and this is our Y. We can make this a tuple. How do I access one thing from it? Would it just be this? I think that, yeah, I think that'll work. That's fine. Okay, so here, how are we calculating this? Y equals mx. Let me. Y equals mx plus b. Okay, m is our coefficient, b is our y-intercept. Um, our coefficient is 5. Our y-intercept is no. Our coefficient is negative 1. Oh, I don't need to. Yeah, okay, okay. The I have the values here. I don't need to remember the values. So it is the coefficient multiplied by x plus our intercept. And then we just copy the same thing here and change this to 1. Okay. We should be able to plot this now. So we do that, and we do that, and that should be it. Okay, dude. All right. Great. Thank you for that. That was super helpful. How did we? Well, okay, you know what? No, that's yeah. Yeah. Okay. I need to scale this. I need to make this scalable. So we're going to keep one. Okay, so let's do what, 5 and then 4 and 1. That's enough. And then we can do something, whatever. Oh God, I have to change these manually. Because the thing is, what the fit method is expecting and what the scatter method and plot methods are expecting, they're like laid out differently. So if I wanted to scale this, I would have to do some stuff. It's not like scaling is going to be hard. It's just going to be a bit. I have to sit and think. That's the thing. That's the issue. All right, so let's do this. What are we looking at? We're looking at X, right? So 31541. Okay. All right. 31541. We also need to change this. And now we plot it. Oh, that's interesting. Okay. Okay. So this is the line of best fit within these data points. Right. I need to make this scalable. I definitely need to make this scalable. So let's do this. Let's do train. So we are not doing prediction right now, right? So we're just going to create the training data. X train data, X train, whatever. Y train. Y is not the training data. Y is just the target, right? Okay. Let's say Y. Though, I mean, we are doing the same thing here as well, right? Y is the training data. X is the features. Y is the target. Should I still be calling Y train? Nah, that's fine. Okay. There is a random method. Does NumPy have? NumPy probably has. NumPy has. Yeah, NumPy has the thing. Because I know. What do you call it? Um, I know. What was that? What was I saying? I know. PyTorch. I think PyTorch or Pandas. One of the two. Or I think both of them have it. Oh yeah, PyTorch has it for tensors. I'm pretty sure NumPy has it as well. There's definitely a random thing. Hold on. There's NumPy dot random dot. There was a. Is it rand int? Rand int. Okay. And random integers of type so and so between low and high inclusive. Wait, so what's the difference between random and or random integers and rand int? New code should use so and so. Similar to rand int. I remember there being a thing where I had to initialize a generator and then use rand int, but I don't remember exactly what the situation was there. Okay. Um. Oh wait, no. Oh I need. Is there a method where I can create? Let me look this up. NumPy random int array. Because I need to be able to specify the shape. Does rand int have this? Yeah, use default RNG to create a generator and call its methods. Okay, okay, all right. Rand int. Is there a thing for specifying the shape? Where's the shape parameter? Because there's low and high. Low, high, size. There you go. Okay, all right, cool. So what are we looking for? We are looking for 1, 1. Actually, we're looking for 5, 1. No, we could do 10, 1. Like, yeah, at that point, we could do 10, 1. And it can be between 0 and 10. And the shape, I'm assuming, has to be a tuple. So this can be 10, 1. And then here we can do random rand int. I mean, dude, this doesn't have to be integers, does it? It can be floats. Actually, I think in some situations it's expecting a float. Should I change that? Maybe I should change that. What if what was the other one? Rand n, I think. Return a sample from the standard normal. This returns, okay, that's just a float. What about rand? Return random values in a given shape. Okay, this doesn't take in shapes. Parameters. Int optional. The dimensions of the returned array must be non-negative. If no argument is given, a single Python float is returned. Okay, let's go for this. I don't know. Okay, this says of a given shape. So that means, okay, what's the difference between rand and rand n? NumPy rand versus rand n. First, as you see from the documentation, rand n generates samples from the normal distribution, while rand n. What is a normal distribution? I've seen this mentioned in stats. I feel like I should learn this. It's probably going to benefit me. But anyways, while rand from a uniform distribution. Oh, rand is between 0 and 1. Okay, that's not what I'm looking for. Yo, welcome to the stream, Sama. How you doing, man? Boo, I'm scared you. You are scared. End of story. Yeah, dude. Hell yeah. Hell yeah. And yes, thank you for the hydration reminder. Give me a second. Dude, I want to do some spooky stuff for the stream, man. I want to do some spooky stuff. I want to try adding some fun spooky stuff to the um to the VTuber app. I could add like a command that you could type in, like you could come in and type boo, and it would, I don't know, show some spooky kind of graphic on the screen. I like that idea. Or it could shoot graphics like across the screen or something like that. I think that would be fun. I could add in music as well. Not music, but like sound effects, like spooky sound effects. Yeah, dude, I could come up with something fun. Or I could connect it to channel points. Do it? Yeah. Hell yeah. I could connect it to channel points, because that way, people will get a reason to use the channel points as well. Because I feel like I haven't done a whole lot of channel points related stuff. There was a bunch of stuff that I wanted to add, and there's still a bunch of stuff that I want to add, but I just haven't gotten around to doing it. Okay, give me a second. Let me do the hydration thing, and then we will get back to this. Okay, all right. So, we need to use. You have 4K points? Hell yeah, dude. Hell yeah. How many do I have on your stream? Give me a second. Let me take a look. Oh, I have 4.2K. I have 4,250 points on your stream. Look at that. We are almost the same points. Okay. Uh Dude, I like that. Nightbot is giving some sass. I like that. Okay. So we need to use rand n. Oh, let me also just look up what is a normal distribution. A function that represents the distribution of many random variants as a symmetrical bell-shaped graph. Normal distribution. Okay, I'll open this up and look at it later. But for now, we need to finish preparing this thing. So this has to be rand n of the same thing, pretty much, but the size should be 10. So for each row, this should also have like one value kind of thing. This is supposed to be a tuple. Um, this is supposed to be a tuple. Yep, this is supposed to be a tuple. So I'm specifying the shape. Um, oh, a bot. Don't you want to buy viewers and be famous? Nah, I'm good. I'm good. Being famous wouldn't be that bad, but like I don't want to like buy viewers. I'm good. I'm good. Actually, I'm good on being famous as well. I'm good on all of it. Yeah, I've set up Nightbot spam filters, so Nightbot automatically catches the thing. And in fact, I developed this technique a couple years ago before Twitch's automod system had gotten better. Now it's a lot better. Now it's honestly a lot better than before. It's a lot more sophisticated than before. So automod is able to catch a bunch of the different bot messages. It's able to recognize that, yeah, this is a possible bot. And then it'll also block the message from coming through. Um, but yeah, there are situations still where sometimes it might not catch it, and so I still have my spam filters set up. Anytime a bot post something new that's not in my spam filters, I'll just copy it or copy a section of it and put it into my spam filters, and then I update it for one of my friends as well. Super convenient. Okay, so now we have our X data and we have our dude, in terms of plotting it, how would we go about doing this? Because, okay, we have our X training data and our Y training data. Okay, so we have X train and we have Y train. Awesome. Great. Uh, Now we want, what do we want? So we are trying to calculate, or we are trying to plot the scatter thing, right? How? Oh, I could do list comprehension here. So we could do X for X in oh no, hold up, wait a second. We need to do X0 for X in X train. So that's our X data, and then this is just our Y data, so we are good. We can just pass Y in here, and we should be good. And I think I should be able to do the same. Oh wait, no, I can't. Who? This is gonna get a bit. No, you know what? We could still do a list comprehension here as well. In here we need to pass in pretty much this list comprehension for X, right? And then I need to make a new list comprehension. I'm just gonna write a new thing here. Do I need to write a new? Nah, it's gonna become too cluttered. So I'm gonna delete the whole thing except for one. Uh, we copy this list comprehension here. Oh crap. We copy this list comprehension here. And then for Y, how are we calculating this? So, um, we want to do X. Oh God, how are we calculating this? It's supposed to be mx plus b, mx plus b. So we want to do L1 coefficient 0 multiplied by x for, so x, y, wait, we are going, we are going per x, right? For x, no, multiplied by x. Okay, multiplied by x plus um, the coefficient, no, the intercept. All right, for x in what? X in, oh, we are iterating over x train, right? So x train is gonna have, uh, it's gonna have the rows. So we are trying to multiply this, right? That should give us our thing accurately. Okay, there's something wrong. Um, Tuple cannot be interpreted as an integer. Tuple cannot be interpreted as an integer. Oh, oh, yeah. Okay, wait. It's not. That was rand int. How do we specify how do we specify a limit? Yeah, how do we specify? Right, hold on. Um, NumPy random float in range. Sampling random floats on a range. Okay, awesome. Great. Let's open that up. Uniform. The uniform distribution would probably do what you're asking. Okay, let's do that. What is it expecting for size? So we have low, high. Size is an int or tuple of ints. All right, yeah, that's probably it. Let's just confirm low and high. Uh, Lower boundary of the output interval, all of the values generated will be greater than or equal to this. Default value is 0. High is the upper boundary. Okay. All right, that does it. Great, cool. Are we good? Yes, we are good. So it plotted this. Let's try that again. It plotted that. Let's try it again. Plotted that. And that. Okay, dude, this is interesting. Hell yeah, dude. I need to reduce the figure size. I think this is a little too big. Uh, Fig size equals, I don't know, let's do 2 by 2. I don't remember if that was the thing. Yeah, there it is. That's much better. Actually, that's not much better. I'm gonna change the size, but it's it fits better on the screen now. Did I just change it back to what it was? No, I think it's smaller than what the original thing was, but it can be smaller. Yeah, that's better. Okay, dude, look at that. So I'm just assuming that this is accurate. I haven't fucked up the calculations. Why is this taking time? Oh wow, why is that taking time? Holy shit, dude. This is this one specific iteration is taking some time. I'm assuming my calculation is correct because I kind of sees that kind of seems like the line of best fit, right? When I'm looking at the data points and then I'm imagining what kind of line would best fit these points, it kind of makes sense. Okay, let's try reducing y and let's keep x long. Okay, so let's see how the line of best fit changes now. Yeah, okay, there you go. All right. Now we could try spreading this out. Um, Okay, let's create two variables, xlim. Uh, no, it should be x. Well, it starts at 0, right? Okay, we can do xminlim. Uh, it can be, I can define the whole thing as a tuple. Xmaxlim, yminlim, and ymaxlim. Right, so xminlim is 10, and then y is, actually I wanted to change this. I wanted to increase it to 20. So then we can do something like this. Right. So then we do x minlim, x maxlim. I don't think I need to change the number of samples. No, yeah, I can still control that. I'm trying to scale the values, not the number of data points. Oh, what did I just hit? I hit Alt. Okay. Uh, Y minlim and Y maxlim. Okay, where else did I need to do this? Here. Here I can do X minlim, X maxlim, Y. I'm going to be playing around with this quite a bit, so I kind of see value in spending time setting all of this stuff up. Okay, let's now plot the thing. Oh, you know what? We can increase the number of. So I'm trying to keep the X small. No, I'm trying to keep the Y small just so we can still see it on the screen, but I'm trying to increase the X. So what we can do is we can spread this out. We can spread X out to 10. And how big does that make it? Yeah, that's better. Okay. Oh, you know what else we could do? I could yeah, I could do this and sample because this is all randomly generated, right? So and features and samples. So the number of features is 1. The number of samples can be, now let's increase it to 20. So let's do n samples, and this is supposed to be n features, and then here we do n samples, and I think we should be good. Great, cool. See, this is what I was talking about when I said that it's not impossible to make it scalable, but it's just going to require a bit of thinking. And then once I started to see how tedious it's becoming to manually enter the values, I was like, okay, fuck this. Let's just set up a thing. All right, so this is 20. This is 20 samples. Yeah, dude, I think I'm getting this right. I think I'm getting this right. I don't think my calculations are fucked up anywhere. I think I'm getting this right. We've set, okay, all right. Let's make it 50 samples. Oh, yeah, when there's more samples, they're going to be spread out a lot more. And so the line of best fit kind of, it gets set accordingly. I think this is accurate. I don't think my calculations are fucked up anywhere here. Yeah, I think this is the line of best fit, right? And I'm kind of proud that I figured out that yes, this is what I have to. Of course, with the help of the LLM, but yeah, I'm kind of glad that I figured this out. Um, in multiple linear regression, if you have more than one independent variable, you'll have multiple coefficients, but the process remains similar. Yeah, I can try this with three-dimensional as well, which would be for two-dimensional or well for two features. Right now I'm just doing it with one feature. I can try that with a three-dimensional thing as well. It's just that in terms of visualization, this works out a lot better. Okay, let's change this to 20. Oh shit, I missed the ad timer. Okay, so there's going to be an ad playing pretty soon. Actually, you know what I'm going to do? I've been sitting for a while and it's kind of starting to make my tailbone kind of hurt, like that area. So I'm going to get up and do a bit of physical activity. Actually, I'm just going to do squats and I'm also going to take a toilet break. So I'm going to BRB couple of minutes because I'm going to do squats for a minute. I'm gonna BRB for a couple of minutes. I would say enjoy the music, but I'm not playing any music. Also, there's the ad playing, so never mind. Right, I am back. Let me transition. Okay, so now I kind of get an I'm kind of getting an understanding of, or rather, I'm able to form like a mental picture of what's going on. So, for me, the next step would be understanding what happens in the predict method. Okay, use the coefficients and intercept to generate predicted values for your independent variables x. Oh, oh, okay, okay. So we basically use the same thing again. We do the same y equals mx plus b for each value in your x data set. Okay, so let's try something. Let's try something here. Okay. Let's say, what are we supposed to pass into predict? Like, what's the shape of the array that we need to pass in? Because I'm trying to pass in one value alone, but I want to see what it's expecting. Array like so and so of shape n samples and features. N samples and features. Oh, okay. All right. I get it. Yeah. So then we have x, and then using x and the coefficient and the y-intercept, we calculate y. Okay. Now let's do something here. Okay. I'm gonna do a thing. Let's print out. Let's say we pass in 6.75. Yeah, let's say 6.75. And let's say, so coefficient 0 multiplied by 6.75 plus L1 dot intercept. What is that supposed to be? 8 point something something. Okay. I want to see how accurate that, I don't know if that number is gonna, I don't know if that number is gonna work well, but we can, okay, okay. All right. So we have plot. We can do another scatter. Can I set the color for this? I think I can set the color for this. Yeah. So I'll set the color for this to red, and the green will be what's predicted. How am I meant to go about this? Okay, let's not try to make this scalable. Let's just do some manual labor here. So this is our scatter. Oh yeah, color. How am I specifying the color? Or I could change the marker. I could change the marker. That works. What different marker types do we have? Okay, hold on. There should be a thing here. Marker. See matplotlib.markers for informations. Informations? No, information about marker styles. Okay, let's do this. Matplotlib. Oh, let's do this as MLP. MLP dot marker. No, okay. How am I? Is there are there examples? There might be examples. Okay, let me just Google this. Matplotlib scatter marker. Okay. Back to what I was saying. Oh yeah, marker. I was looking up marker. Matplotlib.markers. Okay. All possible markers are defined here. All right, let's try this. So let's say marker equals uh, v. Okay, let's plot this. There is our v. Great. Okay. What if I plot another v, but I do it, let's say, a little earlier? Is the color going to be? Oh shit! It's kind of hidden. Let's try that again. Okay, the color is different. Though I prefer um wait a second. Yeah, each time I run this again, the value kind of changes, doesn't it? I'm gonna have to make this dynamic. But that's fine because it's only one that I have to do. Okay. What other thing could I use? So circle is already used. X is something I haven't used. Um, they have a couple different ones here. I could just pick any. I could do plus. I could do X. We can, okay, let's do, right. So we have X and we have the triangle thing. Or we could do a square. What's the square? Square is S. I think it'll stand out pretty well. Yeah, yeah, the square stands out pretty well. So does the X. We could we could set the scale. We could set the scale for these. Dude, I'm doing too much for this. I'm doing way too much for this. Um right, so I'm trying to do X, right? X is because I'm passing in my own custom input. So we can predict here. What should I call this? X test equals 6.75. So that's what we are passing in for the test, right? And then we do L1 dot predict. Does predict return? So yeah, yeah, it's supposed to return, right? It returns an ND array. Okay, we pass in test. Wait, we might have a problem because no, 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 hold up, hold up. Are we gonna have a problem? I don't think we should have a problem. So it says the shape should be n samples and features. I was thinking that we're only going to pass in one value. Yeah, we might have a problem here because if I have to pass in, but like what's the point that I'm trying to pass in one value, right? It's asking for n samples, n features array. N features is 1, but n samples is like 50. Why does it need that for prediction? I was assuming that we could just pass in one value, right? What's the idea there? I think I've misunderstood something here, or I've misunderstood something about the way that this works. You know what? Let's try this. Let's try passing. Let's say x prediction equals this. Let's not plot these. Let's not do this. Is there an error? There is an error because it is expecting n samples and features, right? Expected 2D array got 1D. No, okay, that's not the issue. That's not the issue. Okay, what about now? Holy fuck, it works. It works. Okay, all right, great, awesome, cool. Okay, so 6.75. I calculated. Okay, okay. So here we're going to do two things. We're going to do a manual calculation and then we're going to do. Oh, no, no, no. You know what? Yeah, okay, hold up, hold up, hold up. We're going to do the calculation that I was doing here, right? And then we're going to see what the return was. Why did this say n samples and features? Why did the documentation say n samples and features? I thought that was like a necessary thing. As in it's supposed to be. Oh, okay, okay. So I kind of connected n samples with the n samples that we pass into fit, and n features with the n features that we pass into fit. That's why I was assuming, which I still don't get it. Maybe I just in the moment I might have confused something. This might be one of those things where after the stream I might think about it and somehow I'll have a more clear idea, and then suddenly it's going to be like, oh shit, I didn't think about that during the stream. Okay. So we're gonna do two scatters. One is gonna be the square, which is what I'm calculating. Oh, you know what? We could just do, we could just do this. Does that work? I think that works. Whatever. Okay. Um, and let's bring our calculation here. I didn't need to get rid of this. Okay. And here we can also do test, test 0, 0. Oh yeah, I'm supposed to, yeah, yeah. Okay. It's supposed to be like that and like that. Let me just confirm that that's right. So let's print x test 0, 0. Is that right? That's right. Okay. All right. Great. Cool. So this is going to be mine, right? And then the next one is going to be the one predicted by the model. I want to see if, at this point, I even forgot what I was trying to figure out, but I'm guessing what I was trying to figure out is if it's literally just doing y equals mx plus b, uh, x spread, what is it returning? It's returning this. It's returning an n samples array, right? So I should be able to do it like that. Oh, hold on. I think because they're in the exact same, I think because they're in the exact same location, so I can't see them. Let's make, let's make this thing size bigger. Let's make x's size bigger. A float or an array. Okay. The default is this. I don't know what the default is, but let's say s equals, I don't know, 5. I think it needs a float. Like, was that enough or was that too much? Hold on. Let's try that again. Where's the X? Oh, is that the X? Is that the X there? The tiny thing there? I think so. Let's crank it up to 50. Maybe too much, but like, let's see. Oh, yeah. Okay. It was less. Okay. So we are doing 150. Much better. Great. Hell yeah, dude. Okay. Okay. All right. All right. So it basically uses the line of best fit. So whatever input you're going to give it, that input is going to lie somewhere on the line of best fit. What happens? Okay, now it gets interesting. What happens if I give it something past what it has been trained for? How is it going to predict then? I don't see it. Oh, it's because it's off the grid. Size. No, size limit. Okay. So let's set the limit to 30 on both of these. Oh shit. Wait, no, that's okay. Hold on. I'm trying to set the limit for this and limit. Yes. So I'm trying to set, okay, let's redo the x limit. Let's take the x limit to, let's say 30. I want to see where the point lies. Oh, that's interesting, dude. So even outside of the training data range, it still seems to be following this line. Okay. All right. Great. Cool. There's a lot, dude. There's so much for me to explore here. There's a lot more for me to explore here. Um, the first thing I want to do is I want to. So right now I'm doing like just it's just a whole lot of noise, right? It's a whole lot of just random values. What I want to do is I want to try creating my own sort of linear map. I want to try and map so and so values to so and so values, and then I want to see how well the model how well the model predicts that given an given an x value. But dude, I'm excited. I'm super happy because I'm getting a better understanding of linear regression. I can say now that I understand a lot more than I did at the beginning of the stream. So I've definitely learned a bunch of things. I 100% have an idea of what is being passed into the fit method, what is being passed into the predict method, the difference between our training and test data sets, and there's a ton of experimentation for me to do now. There's so much more that I have to do with this. There's a lot more like playing around that I have to do with this because I've set up this thing right now to have just random data points, right? I want to create, like I mentioned earlier, I want to create like a I want to create like a deliberate mapping. I want to create like my own mapping where I do something as simple as mapping one number to another, and I want to see how well the linear regression thing predicts the input after that. Because I feel like there's something interesting to be studied there, specifically about mapping one input to another. And this is all in like one dimensional space, but then the interesting thing here is that you're not limited to just one dimensional stuff, or okay, I'm saying one dimensional in the sense one dimensional features. You can increase the number of features. It might become Actually it will become harder to visualize it after that, but the calculation still works. So you can increase the number of features and get better predictions that way. I need to explore that as well. I also need to explore what the calculation is like when you have multiple features. That would be something interesting to look into. How the calculation change, because I feel like at some point it might become a matrix calculation, right? If you have like multiple values. I think so. I'm not sure. I'm gonna have to, like I said, I'm gonna have to explore. I'm excited. I'm excited. There's a lot for me to look into. Um, and I'm gonna spend some time with this, dude. I'm gonna spend some time with this. I'm excited. Okay, now hold on for just a minute. All right, here's what we're gonna do. Okay, I'm gonna end the stream here, and I'm gonna rate this person called Astray Ray. They're doing some stuff in Godot. They are working on a game for Ludum Dare Game Jam. That's a name I haven't heard in a while. So let's go check out their stream. Um, Guys, thanks a lot for hanging out. Summer, thanks for hanging out and chatting and stuff. Anyone else who might have been lurking in the chat, thanks for hanging out. I'm super excited to explore this more, especially now that I have a better understanding of the calculation that's happening. I'm excited. I'm going to carry on exploring this. I'm probably going to go and eat something, and then I'll carry on. I'll see. But that being said, I hope you guys have a nice day, and I will see you all next time. Peace.